Hey everyone. Okay, this is going to be the answer key for J8. I'm going to split it up into a few videos, so just keep track of which video contains which questions. So really for all of these, when we're talking about a composite figure, what we're talking about is a figure or a shape that's made up of multiple shapes combined. So notice that this shape in question A, for example, kind of looks like a house you would draw as a little kid, but fallen over on its side. That itself doesn't have a name. That itself doesn't have a formula. But we can split it into two different shapes that we do have formulas for. We have this rectangle here, and we have the triangle on the other side. If we split this into different shapes, we can find the formula for each of those and then combine them. Sometimes when it comes to composite shapes, we're going to add pieces together. Sometimes we're going to find a whole space and then subtract out what shouldn't get included. But in a question like this, I would strongly suggest taking the two different shapes and combining them together. So looking at the rectangle, an area for a rectangle, if you think back to a couple of chapters ago, area for a rectangle is going to be 10 times 8, right? It's my base times my height. So the area of this space is going to be 80 meters squared. For the triangle portion, we have base times height divided by 2. And remember that when it comes to base and height, they're always going to be perpendicular to each other. So notice we have perpendicularity right here, which means if this is the height of the triangle, this is the base we're going to refer to. They don't exactly label the base, but they do show me on this side that I have 8 meters. And if this is a rectangle, because these are perpendicular, it means this is also 8 meters. So my area for the triangle is a base of 8 times a height of 6, divide by 2. So we have 48 divide by 2, giving me that the triangle has an area of 24 meters squared. And now we combine. The area of the whole thing is my 80 meters squared plus my 24 meters squared, giving me an entire area of 104 meters squared. That is our area for this entire composite figure. Question 1b. Once again, we are looking at a rectangular shape and a triangle, two separate pieces that we can look at individually, and then we can combine them in the end. So we have this, what looks like a right triangle up here, right? If this here is a right angle, then this here is a right angle. We also have this rectangle, or technically a square on the bottom. Now, how do I know it's a square and not a rectangle? Think about that for a second while I color it in. Okay, so I know that this rectangular shape is actually a square because they've marked that the sides are congruent. They show that this is 12 and therefore this is 12 meters. We also know that all the angles are right angles, which allows me to know that this isn't a rhombus, it specifically is a square. Okay, so if I want the area of the two separate pieces, the area of the square can be treated like a parallelogram, like a rectangle, base times height, which really just means side times side, or side squared. So that square has an area of 144 meters squared. The triangle, base times height divided by 2, we have a hypotenuse of 13, but that is neither the base nor the height. The base, this part right here, I can see is also 12 if this is a square. And now in order to know the height, the side that's perpendicular to this other side, I don't have any other information as far as measurements, so I can do a little side calculation. I can do the Pythagorean theorem. If my triangle has sides of 12 and 13, I can either remember my my Pythagorean triples, or I can calculate 12 squared plus our mystery side squared equals 13 squared. So that's 144 plus x squared equals 169. Subtract the 144 and I get 25, which means if I take the square root, our mystery side is 5 meters. Now I can do my area. My base and my height are the two sides of the right triangle that are perpendicular to each other. So that's where we have a base and height of 5 and 12. So we have 5 times 12 divided by 2, and we're going to get an area of 30 meters squared. Now to find the total area, we combine the two that we found. We have 144 meters squared from the square, plus another 30 meters squared from the triangle. So we have 174 meters squared in total for this composite figure. Okay, moving on to question 1C. Okay, they even give us a note here. This note says the cut out portion is a quarter circle, meaning 1/4 of a circle. And they emphasize that it is cut out. So really what they're saying is that we have this square-like shape here, and then 1/4 of a circle was cut out. So we're going to eliminate this much of the square. Okay, hopefully that makes sense. So this is what is cut out. So in a situation like this, I would never suggest to try and split this shape up into different shapes you do know. What I would do is find the area of the square, and then I would subtract the area of the quarter circle. Not half, quarter circle. So the area of the square, we have this side is 20, this side is 20. I know they're marking 10 over here, but that's only because we're not looking at the full side to begin with. It is a 20 by 20 square, which gives me an area of 400 centimeters squared. To find the area of a full circle, we have pi r squared, but I want 1/4 of that. So 1/4 times pi r squared, and our radius over here, if this portion over here is 10, and this whole side is 20, then I know this radius is also 10. So we have pi times 10 squared. So that's 1/4 times 100 pi, and that gives me 25 pi when I multiply it by 1/4. So 25 pi centimeters squared is the area of my quarter of a circle. And like we said, we now subtract. I'm looking for the full area. I have 400 centimeters squared minus 25 pi. Type that into your calculator. 400 minus 25 pi. That is not 400 minus 25 times pi. It's 400 minus 25 times pi. So I'm going to get approximately 321.5 centimeters squared. Okay, moving on to question D. Once again, we have a shape that looks more like it has a portion cut out. If you were to ask me, I would say I could look at this as a full rectangle, right? A 6 by 4 rectangle. And then it looks like this triangular portion is carved out of the full rectangle. So I would start off by finding the area of the rectangle, which is base times height, or in this case, it looks like a 6 by 4. So that's 24 meters squared. And then I'm going to subtract the area of the triangle, which is base times height divided by 2. If down here is worth 4 meters, then up here is worth 4 meters. And they're telling me that perpendicular to that base is 2 meters. So my height is 2 meters. So I have a base of 4 times a height of 2 divided by 2. That's 8 divided by 2, or I can just cancel the 2's out right now to realize that that triangle has an area of 4 meters squared. And then don't forget, we're going to subtract. So we get a final area of 20 meters squared. Okay, question E. You have options here. I could try and split this up into 3 different pieces. I have a rectangle, and a rectangle, or I can try and split it this way if I really wanted, into this shape, and this long shape. I could also look at it like I did in the last 2 problems, where I can close it off here and look at it as one big rectangle with a portion cut out. I'm going to choose that way only because that's only 2 calculations before I add or subtract, instead of the other method that forced me to split it into 3 different things. No matter which way you do it though, you should get the same result in the end. So like I said, I'm going to choose to look at the full rectangle, which is 15 millimeters by 30 millimeters. So the area of the rectangle is 15 times 30. That's my base times my height. So I have an area of 400, yes, that makes sense, 450 millimeters squared. Then I want the area of the rectangle that's getting cut out. So this is the area of the yellow rectangle. And that has dimensions of 8 millimeters by 10 millimeters. So that's 80 millimeters squared. And now we're going to subtract that yellow rectangle from the overall rectangle. So 450 minus my 80 gives me an area of 370 millimeters squared. Okay, one more for this video. Question F. Looks like I'm splitting it right along here. So it looks like I have a rectangle and I also have a semicircle. I have not a full circle, but it looks like half of a circle. So I'm going to combine those 2 areas. So the area for the rectangle is base times height, which in this case looks like 6 times 4, giving me an area of 24 centimeters squared. To find the area of the circle, I want pi r squared, but I only want half of it, right? So I have to make sure that in the end I cut that in half. My radius here, if this side is 4, then this whole side is 4, which is the diameter. So my radius is going to be 2 centimeters. So I have pi times 2 squared over 2, which is 4 pi over 2. I can reduce and find that my circle has an area of 2 pi centimeters squared. And now I combine. Area equals 24 centimeters squared plus 2 pi centimeters squared. So 24 plus 2 pi. I do that in the calculator. It's not 24 plus 2 times pi. It's 24 plus 2 times pi. So that gives me an area of approximately 30.3 centimeters squared. Let me know if you have questions and move on to the next video.